So how do we increase the PSRR in an LDO? So the way to you can improve the gain is to increase the gain in this feedback path. Increase the gain here, or if we cannot increase the gain, we can decrease the ESR of the capacitor, output capacitor. So the output capacitor ESR is typically there in parallel. So this is the RC that is present. So if you can reduce RC, okay, either you reduce RC or you have to increase the output gain of the feedback, which I will call it as A feedback, right? So this feedback, if you increase, then you will get a better LDO. So how do you choose? So the important point that you will have to look into is a well-defined amplifier and a proper selection of the output capacitor are crucial to get a good PSRR response. So what are the important things that you need to take care when you have a good error amplifier or an amplifier here? First one is you need to look that it has high gain, at least in the areas of from DC to 100 megahertz, which is typically done. You have to look to the bandwidth or the 3 dB bandwidth, right, is expected to be a little larger than 100 megahertz, such that you see better. Ideally, it would you could look at say 500 megahertz to give you a much better response. And third one, which is typical of all things, is how much gain margin and phase margin is present in this design. So these are the key elements that you have to answer. And one of the reasons why PSRR is better with the PMOS, we have answered in the previous slide. Also, we see that there is an inherent the drop, that is a VD-SAT, is taken into consideration. Apart from that, there is no other drop here. There is only this VDS drop which is expected. Whereas in a PMOS device, apart from this, you will also see a little more VGS drop seen, where you will have the drain cap present, which will further impact the gain of the feedback path, and also it will reduce what is going to be a PSRR gain present at that particular value.